Okay, today we are actually going to skip to section 6.2. Since I'm gone, this would be an easier one for you to do without me. I would like for you guys to make sure you are watching the entire video before you start your handout. That will be for homework. Make sure you are taking notes as you go through this. So we have looked at radicals and exponents to some extent. What we are going to take into consideration today is how to graph exponential functions. We'll start with the definition. If I'm talking about an exponential function, it's something of the form f of x equals a to the x. In other words, you have a number to a power, but your variable is the power. So 3 to the x, 5 to the x, 1/7 to the x, those would be exponential functions. The base, that's the a, has to be something other than 1, because 1 to a power is always 1. That's not very interesting. So that number, the a, is your base, the x is your exponent, and that is where the variable occurs. What I want to do is graph a couple of these and see if we notice any patterns. So the first one we're going to look at is f of x equals 2 to the x. I'm going to graph that by making a t-chart. So if we put in a 0, 2 to the 0 power, anything to the 0 power, is 1. So I have the point 0, 1 on my graph. If I put in a 1, 2 to the first is 2. So 1, 2 is on the graph. If I put in a 2, 2 to the second power is 4. So 2, 4 is on my graph. I can keep putting these in. If I put in a 3, 2 to the third be 8. It's just going to keep rising. Let's go the other direction. Let's put in some negatives. If I put in a negative 1, 2 to the negative first, a negative power changes floors. So 2 to the negative 1 power would become 1/2. If I put in a negative 2, 2 to the negative 2 power. So that's 1 over 2 squared, so that would be 1 over 4. Now you'll never do 2 to a power and get 0 or a negative out. So what we see is our graph looks like this. The x-axis here is acting like an asymptote. Remember, we talked about those before. It's a line that we're getting closer to without actually touching. If I look at this graph, my domain, I can plug in any number. As I go from left to right, it extends both directions, so the domain would be negative infinity to positive infinity. My range, if I'm looking at my y's, it starts at 0. We never actually hit 0, so that's a parenthesis, comma, keeps rising forever, so 0 to infinity. Going from left to right, this graph rises the whole time, so it is increasing from negative infinity to infinity because we use the x values. And then asymptotes, we have a horizontal asymptote at y equals 0. Next, I want to look at 1/2 to the x. So again, let's start with our t-chart. And let's just plug in all the same numbers. So if I put in a 0, 1/2 to the 0, anything to the 0 power, is just 1. If I put in a 1, 1/2 to the first would be 1/2. If I put in a 2, 1/2 squared is 1/4. If I put in a negative power, the negative would flip this. So if you flip 1/2, you just get positive 2. If I put in a negative 2, The negative flips it, so it becomes a 2 squared, which would be 4. And so we're getting a very similar graph, except it switched direction. Again, we'll never get out 0 or a negative, so our graph will look like this. So domain, going from left to right, again, we will hit everything. It keeps going both directions, so that's just negative infinity to positive infinity. The range starts at 0 without hitting it and goes up forever, so 0 to infinity. As I go from left to right, this graph is decreasing the entire time. But we again have the same horizontal asymptote of y equals 0. So with these exponentials, we see a few things in common. It's either increasing or decreasing, depending on the base. If your base is bigger than 1, as in 2 to the x, then the graph is increasing. If your base is smaller than 1, like the 1/2 to the x, then it is decreasing. They both have a point in common. They're going to always go through the point 0, 1. And the x-axis will act as a horizontal asymptote every time. So now we are just going to practice graphing some more of these. In general, I am going to ask for you to do 3 points on every graph. All I am going to require you to plug in is -1, 0, and 1. If you need more, graph more. That is your minimum. So if I have 4 to the x, 4 to the -1 power would be 1/4. If I put in a 0, 4 to the 0 is 1. If I put in a 1, 4 to the first is 4. And so I will be looking for those 3 points on your graph, and that you have your asymptotes in the correct spot and a nice smooth curve. For B, again, just 3 points. So if you put in -1, 1/3 to the -1, the negative would flip it and you get 3. So -1, 3. Put in a 0, 1/3 to the 0 is 1. Put in a 1, 1/3 to the first is 1/3. Both of these graphs have a domain of -infinity to positive infinity. If I were to ask that, they both have a range of 0 to infinity. I just want to continue this graphing idea, but we're going to start throwing some other pieces into it. We're going to look at transformations. So for each of these, we are going to graph the parent function, then the transformation, and then give domain and range. When you are trying to decide your parent function, it's just a number to a power. So my parent function here is 3 to the x. Okay, I'm just going to verbally talk through the 3 points on that. If you put in a -1, 3 to the -1 is 1/3. If you put in a 0, 3 to the 0 is 1. If you put in a 1, 3 to the first is 3. I would like for you to draw your parent function as a dashed line, please. And of course, if you want more than 3 points, you can put in more. The negative in front, a negative out in front, it's essentially making all of your y's negative. So that will flip my graph over the x-axis. Okay, so this point will go down here. Every point flips over. looks something like this. My domain, every single time, will be the same. It's just a negative infinity to a positive infinity. The range here, because I flipped it, it did change. Your range, remember, goes from the bottom up. So from the bottom, this thing is going to negative infinity. And it stops right here at the x-axis, which is 0. We never hit that axis, so it gets a parenthesis. I'm going to do a couple more with the same parent function. So now I want to do 3 to the x minus 2. So again, my parent function is just that 3 to the x. If you put in -1, you get 1/3. If you put in a 0, you get 1. Put in 1, you get 3. Sorry about the bell there. Okay. Then this -2, it is attached to the x, it's in the exponent. Remember, anything attached to the x moves it left and right. So the -2 will move our graph right 2. So take each of our points right 2. And there's our graph. Domain, every single time, is the same. Negative infinity to positive infinity. The range starts at 0 and goes up, so 0 to infinity. One more. 3 to the x, but this time the -2 is on the end. So parent function is the same, 3 to the x. So if you put in -1, you get 1/3, 0, 1, 1, 3. This -2 on the end is going to affect my y, so that will move my entire graph down 2. When you move up and down, you have to move your horizontal asymptote with this. This had an asymptote at 0, so if I go down 2, my asymptote is now at -2. Then move each of your other points down. Domain is just negative infinity to positive infinity.
You want me to put the door?
Range, because we shifted this graph down, we can see our lowest point is at -2. We don't actually touch it, so it gets a parenthesis, comma, keeps going up forever, so -2 to infinity. Okay. We're going to do 2 more examples, and then we'll be done with this. The next one, 2 to the -x minus 3. So our parent function here is just 2 to the x power. So you need your 3 points. If you put in a -1, 2 to the -1 is 1/2. If you put in a 0, 2 to the 0 is 1. And if you put in a 1, 2 to the first is 2. So this is our parent function. Graph it with a dashed line. And then we have to look at our transformations. The -3 would move the whole graph down 3. If there is a negative on the x, it makes all of your x's negative, so that will flip it over the y-axis. Because we moved up or down, that moves our horizontal asymptote, so it was at 0, now it's going to go to -3. Then I'm going to take each of my points, move them down 3, and then flip over the y. When I move 0, 1 down 3, it's already on the y, so when you flip it over the y, it doesn't go anywhere. And move your final point, flip it over the y, it goes here. So our graph will look like this. I didn't ask for domain and range on this one. If I did, domain every time is negative infinity to positive infinity. Range would be -3 with a parenthesis, comma, infinity. And our final graph. F of x equals -4 to the negative x power. So our parent function this time is just 4 to the x. When we graph this, we put in our -1, 0, and 1. So if you put in -1, 4 to the -1 is 1/4. If you put in 0, 4 to the 0 is 1. Put in a 1, 4 to the first is 4. Draw that with a dashed line.
Please, just a reminder to you that you...
A negative on the x makes all of your x's negative, so it flips it over the y-axis. The negative out in front is essentially making your y's negative, so it flips over the x-axis. So 2 flips this time. So if I flip this one over the y, it'll go over here, and then flip it over the x, comes down here. 0, 1, if I flip it over the y, it doesn't go anywhere, then flip over the x and it goes down. -1, 1/4, flip over the y, it goes to +1, flip over the x, it goes to a -1/4. And so this would be my final graph. Didn't ask for it, but domain -infinity to positive infinity. Range this time would be -infinity to 0. So that is the end of this graphing piece. Your substitute has a handout for you, so get that from her, and this will be due on Monday.